Welcome back. This is an Aleks training video on predicting bond angles in molecules with one central atom and no octet rule exceptions. Bond angles are not something that I want you to memorize. There's no reason to memorize it. You can look it up in books. The more you play with something, the more you'll use, the more you use it, the more you'll remember it. The less you use it, who cares? There's some that are obvious. So for instance, if you have a straight line, you know that's 180 degrees. That's linear. If you were to have three atoms on the same plane, it's going to get away from each other. That's dividing 360 by 3, you'll get a 120. Those are obvious and predictable. But the ones like a tetrahedral being 109.5, just look it up. You can look it up. There's a data button on Aleks. Use it. So in this problem, they're asking us to find what are the angles, okay, of the carbon-hydrogen bonds. Okay, they're not asking for all the angles. They're only asking what are the angles from the between one carbon-oxygen bond and one of the carbon-hydrogen bonds. Okay, so this is formaldehyde. I think they use it in mortuaries. But in any case, you're going to need a Lewis structure. If you're going to know what its shape is and what the angles are and such like that, you have to know what its shape. Then you're going to need to do a Lewis structure. So the first thing you're going to need to do is find out what's your central atom. You're looking for the lowest electronegativity that can hold hands with the most things. So if you look at oxygen's in group 6. It can hold hands with two things. Group 7 can hold hands with one thing. Group 6 can hold hands with two things. Group 5 can hold hands with three things. Group 4 can hold hands with four things. Group 1, like hydrogen, can only hold hands with one. So carbon here is your obvious choice. It's got a low electronegativity. It has four bond places, right? It has 4 in its outer shell, but it needs 8, so it can share with 4. So it makes it perfect for a central atom. So if I do carbon here as a central, and I put oxygen up here somewhere, put hydrogen here somewhere, and hydrogen here somewhere, just because I wrote it down doesn't mean that that's the angle. It's not a 90-degree angle. I have no idea what the angle is. I just put it somewhere. And the next step, remember, is to find out how many valence electrons totaled. How many do we have to play with so that I know where to put them? So carbon has 4. Okay, it's in group 4, so it has 4. Hydrogen has 1, but there's 2, so the 2 hydrogens have 2. And then the oxygen is in group 6, so it has 6. So this is 4 and 6 is 10 plus 2 is 12. I've got 6 pairs to play with. Okay. Well, first thing I would do is just make some bonds. So there's 1, there's 2, there's 3. Okay, I need an octet around carbon, and that's a problem because there's nothing else attached to carbon. So my guess is I'm going to have a double bond. Let's finish the oxygen and see if I have leftovers. So oxygen has 2 right now. Okay, there's 4. There's 6. I've got 1, 2, 3, 4, 5. I have one more pair, and I need some on oxygen and some on carbon. That tells me I need a double bond. So I'm going to put a double bond here. Okay, so I have single bonds on the hydrogens, double bonds on the oxygen, and the 2 lone pairs on the oxygen. No lone pairs on the carbon. All right, so I'm wanting to know what is it? What are the angles? Okay, and I'm asked to find the angle between the oxygen carbon and the oxygen hydrogen. All right, the oxygen carbon and the oxygen hydrogen. So I want this angle right here. Well, okay, so carbon, oxygen's going to be like sticking straight up, and then how far over is the hydrogen in such a way that all three of those stay away. So there's electrons on the hydrogen, electrons on the oxygen, and they want to stay away from each other, and they want to go as far apart as they can. Okay, so what do you think? You've got three groups of electrons coming off of the carbon. So I'm going to come over here to my picture, and I'm looking for AB3, and it says triagonal planar, okay, to where that they're all at equidistant away, like that, with the carbon on the inside, oxygen to the top, hydrogens to the side, and then this will be 120 degrees. And that's what you'll say. It'll be 120 degrees, and that's how you find out. Okay, so, you know, I have no trouble with you looking it up in the book and finding out what these bond angles are, but you have to still be able to figure it out, and that's why it's hard.